See, in this problem, uh, it's actually a double slit experiment. So these are slit 1 and slit 2, and two glass plates are there, and they are having same thickness T. So this glass plate also thickness T, and the lower glass plate also thickness T, but they are having different refractive indices. So mu1 and mu2, and there is a screen. So let us choose this the midpoint. That means this is the point of y is equal to 0. Okay, let's put down the values first. So t is equal to 0.5 millimeter, right, and mu1 is equal to 1.58 and mu2 is equal to 1.55, and wavelength of light lambda is equal to 590 nanometer, and the interference is observed at the screen at a distance. This distance capital D is given as 1 meter. What would be the fringe width? Actually, fringe width does not depend on all this, right? Fringe width is lambda into capital D divided by small d. So after calculation, this comes out to be 4.9 multiplied by 10 to the power minus 4 meter. This is the fringe width. Beta stands for the fringe width. Okay, now next part, what has been asked, this part B, at what distance from the center will the first maxima be located? So let us locate the central maxima. So let there be a point P where you have the central maxima, and for the central maxima let the coordinate be y naught. So at y naught, at y is equal to y naught, there is central maxima. And see, as you know, at the central maxima the optical path difference is 0. So there S1P, H2P, like that. So at P, this S2P minus T plus mu1T, right? This is the optical path, is equal to, so at P, as it is a central maxima, the optical path travelled by light is same from S1 to P and from S2 to P. So S1P minus, it's minus T, right? S1, this S2P minus T plus mu2T, right, is equal to S1P minus T plus mu1T. So we can just equate this. So therefore S2P minus S1P is equal to mu1 minus mu2 times T. Now S2P minus S1P is how much? As we have done these things before, see S2P minus S1P, if you remember that, see S1P and say S2P. So as these rays are almost parallel to each other, so we drop a perpendicular from S1 onto the line. If this angle is theta, angular position, see if you look at this figure, so angular position of the point P is theta. So if you drop this perpendicular, so that so S2P minus S1P, the geometrical path difference happens to be d sine theta, right? So therefore we can predict, so S2P minus S1P, so d sine theta is equal to mu1 minus mu2 times t. Now, as theta is small, so sin theta is nearly tan theta. So we can write sin theta is approximately equal to tan theta is equal to y naught by d. So therefore d y naught by d is equal to mu1 minus mu2 into t. So therefore y naught is mu1 minus mu2 t d divided by small d. So this is the y coordinate of the central maxima. Now, so you have to find the coordinates of the first maxima, right? So as you know, first maxima, see on the screen here, this point P is the central maxima. So you have two first maximas, right? First maxima means where the path difference is lambda. So you have two first maxima at a distance of beta, where beta is the fringe width. So coordinates of first maxima are y naught plus beta and y naught minus beta. So after calculating this, you get point, see this, so y, so we can write ry is equal to y naught plus beta and y equal to y naught minus beta. So you get two values. One is plus 0.028 centimeter and you get minus 0.021 centimeter. That means it is to the other sides of the central matrix and of this y equal to 0 central line.